Hey guys, what's up everyone? How are you guys doing? Hoping that all of you guys are doing good and taking very good care of yourself. Welcome back to today's session. This is going to be magnetic effect of electric current session number 2, where we'll be talking about the magnetic fields due to the current carrying conductor, a straight current carrying conductor, a loop, circular loop current carrying conductor, and also a solenoid as well. So without any further delay, let us get into it. So as always guys, the code for today is this: never do tomorrow what you can do today. Procrastination is the thief of time, and I can attest to this. It's very true, because I have been known for someone, I have been known to procrastinate at times, and it is something that definitely steals away your time, and you feel like you can do it tomorrow, but then by the time you've reached tomorrow, you know that you want to do it the next day, and it goes on and goes on and on, and it's something that is never going to yield you a good result. So don't ever do that. So please make it a habit to do whatever you're supposed to do in that day itself, right? There's a saying, no, aaj kare so aaj kar, kal kare so aaj, something like that. So yeah, goes on like that. So that is it guys. With that said, let us get into it. And I shouldn't have tried it, but yeah. So people, in the last session we talked about magnetic field and magnetic field lines. We are going to talk about magnetic field lines due to the current carrying conductor. In the next session we'll talk about the force on current carrying conductor in a magnetic field as well. So people, in the last session, magnetic effect of electric current, we had asked you homework, and the homework for this, who discovered the magnetic effect of electric current? It was none other than Hans Christian Ørsted, or H.C. Ørsted was the one who actually discovered the first ever magnetic magnetic effect of an electric current. And I told you the story also, yeah. So remember that. All right. With that said, guys, let us now get into the topic for today. That is magnetic field of current carrying conductor. So let's take an example, guys. Like I told you, we'll be talking about straight wire, circular loop, as well as a solenoid. So let's start with a straight wire. So imagine there's a copper wire, which is a conductor, obviously, and it's a straight wire. Now, what I'm going to do, I'm going to connect it to a battery such that the current starts flowing through it. Very simple. So I'll connect one end to the positive terminal, the other to the negative terminal of the battery. Very simple. Now, as soon as you turn it on, what happens? The current starts flowing through it, and as the current is passing through it, we have seen that there's a magnetic field also created. And if I were to bring a magnetic compass near it, you see that there will be deflection in the needle of the compass, which clearly states that there is a magnetic field around that current carrying conductor. Awesome, we have seen that in the last session. Now, here's the thing, guys. What I'm going to do is that I'm going to try to find out what does the magnetic field lines look like, and also what is the direction of the magnetic field lines. So what I'm going to do, I'll just take a sheet of paper, place it, pass the current carrying conductor through it. It basically looks like this. So if you have to look at it in the 3D picture, so this is the paper, I'll pass the current carrying conductor through it. Very simple, all right? And one end is connected to the positive terminal, the other is connected to the negative terminal. What I'm going to do is that I'll take some iron filings, like we did in the last session, and place it around this paper. So what happens is that as soon as you place the iron filings, immediately you can start seeing some kind of pattern being developed in that particular paper because of the iron filings, and it basically looks like a circular pattern. You see, if you look at it very carefully, you can see some circles around this current carrying conductor. Now here's the thing, guys. In a straight line, in a straight current carrying conductor, the magnetic field lines look like this. It looks like concentric circles, that is one after the other. You can see so many amount of circles being passed. Again, depending on what is the strength of the magnetic field, you can see that there is the magnetic field lines will be produced accordingly. Now, if I want to find out what is the direction of the magnetic field, is it is it clockwise direction or is it anti-clockwise direction, there is actually a way to do it. And it's as simple as using your right hand. And that rule, my friends, is called as the right hand thumb rule. So it's very simple. Imagine this is a current carrying conductor, right? This is a straight line, all right? And let's say the current is passing this way. So that means this end is connected to the positive terminal. This is connected to the negative terminal. So what I have to do is very simple. Take my right hand and grasp this particular current carrying conductor. Now, when I grasp it, what I have to keep it in mind is this. I have to think about the direction of the current. So if the current is flowing this way, that means my thumb has to point that way. So if the current is passing this way, I have to grasp it like this. Now this time the current is flowing this way because it's connected to the positive terminal. This is connected to the negative terminal, so the current is flowing this way. So what happens is this. My thumb represents the direction of the current, whereas my fingers, which are grasping this pen right now, this represents the direction of the magnetic field. So this is what it looks like. So basically, when I hold it, the current is I and B is the magnetic field, which is represented by the fingers that is grasping this particular conductor. As simple as that. Now you could use this rule pretty much for even for a circular conductor or circular loop, or you can use it for a solenoid as well. It holds true for pretty much all kinds of conductor. I'll tell you how. I'll tell you how, because I'm pretty much thinking that yes, you guys might be thinking, sir, how is that? If this is what a straight line conductor, then how can you use it for a circular conductor? I'll tell you that in a minute. But yes, guys, it's as simple as that. So we use the right hand thumb rule. When you grasp it, what happens? The thumb represents the direction of the current, whereas your fingers, which is grasping it, shows the direction of the magnetic field. As simple as that. So yes, guys, now let's talk about the magnetic fields due to a current carrying conductor if it's a circular loop. So let's imagine a circular loop which is connected to a battery and a plug key as well. So you turn it on, the current starts passing through it, and obviously there's a magnetic field also created around it. So let's try to find out what is the direction of the magnetic field like, and also let's try to figure it out, like what is the direction of the current and everything per se. Now, here's the thing, guys. What I can do is that I can imagine the circular loop to be like basically like a straight line conductor being joined at a certain point. So I can imagine that there are so many straight line conductors like this. Instead of a circular loop, I can imagine like this. Very simple. I can do it like this. So I can just connect it like with singular wires and straight line wires. Now, if it's a straight line, if it's a straight current carrying conductor, we have just seen that if you use the right hand thumb rule, you'll be able to find out the direction of the current. You'll be able to find out the direction of the current as well as the direction of the magnetic field as well. Now, so in this case, this is connected to the positive terminal and this is connected to the negative terminal, right? This is connected to the positive terminal and this is connected to the negative terminal of the battery. So positive, negative, right? Now, so the current starts flowing from here, comes back over here. Very simple. So what I'm going to do, I'm going to use my right hand thumb rule. So I'm going to grasp this particular straight line conductor and I hold it, and I see that the direction of the magnetic field is basically, or the magnetic field lines is basically a clockwise directional current. So here also it's going to be the same, clockwise. Here also, when I hold it this way, again it's going to be this time it's going to be inwards, so the direction is going to be this way. So it's again going to be clockwise. Here if I hold it, again the direction of the current, again clockwise, and so on and so forth. So basically it would look like this. So basically the current is flowing in clockwise direction, or the magnetic field lines are in clockwise direction. Now here's the thing, guys. What I'm going to do is that I am going to put a paper in between. So basically like this. So I'm going to put a paper in between and pass the circular coil through the paper, and I'm going to connect it to the positive terminal and the negative terminal of the battery. So what happens is that there'll be magnetic field lines formed. At each and every point there'll be a magnetic field line. So if I were to put some iron filings on the paper, the iron filings would take a shape like this. So basically there'll be concentric circles over here and there'll be concentric circles over here as well. And if you look at it very carefully, you can see that as it comes to the center, the magnetic field lines is becoming a little less curved. And at the center, especially at the center, it'll be a straight line. Now people, we talked about a simple bar magnet in the past, right? And in a simple bar magnet, we saw that basically if this is the North Pole, if this is the South Pole, the magnetic field lines basically emerge from the North Pole and ends in the South Pole, right? Emerge north, end in the south. And basically this is what we saw, right? This is what it will look like, right? And the direction is basically towards the south, right? Ends over here. Very simple. Now, if you look at both of them very carefully, do they somehow resemble each other? Does the magnetic field lines resemble? Take a second and look at it very carefully. Do you think that it resembles how the magnetic field lines in a bar magnet looks like? Absolutely yes. But yes, I know that this might be a little hard for you to imagine. So what I'm going to do is that I'm going to tilt this circular loop this way. So I'm going to tilt it this way. So basically it will look like something like this. It'll look like this, right? This I'll take it as a front side. This is the front. So the current is passing this way. So this will be the front side. Yeah, the current is passing this way and it's going back like this. So current is flowing like this, right? So that's the front side, that's the back side. Now, if I were to find out what is the direction of the magnetic field lines at, let's say, this point and at this point, just to make my life a little easier. That's all. It's easier for you to imagine. All right. So at this point, the current is passing this way. The current is passing this way. So if I were to draw the magnetic field lines, this would look like this, right? Now, what is the direction of it? It's going this way. So the direction is basically, it is passing its clockwise direction, right? Over here also, you see this, over here the current is passed, so the thumb is pointing outside the screen right now towards me. So when I place it like this, look at my fingers, it's folding towards this way, right? So basically the direction of the magnetic field lines would look like this, right? Downwards on the outside, and on the inside it's upwards. Very simple, as simple as that. Now, if you extend this is what it will look like, right? Basically, just like what we did before. And the center, it looks like a straight line. Now, at all the cases, you see this is going from here and ending over here, right? Going from here and ending over here. Here, going and ending over here. Now, if you look at it, does it resemble almost the same? Absolutely, yes. Now, in case, if you can't imagine further, if you reduce the size of the magnet, to this, let's say this is the North Pole and this is the South Pole, the magnetic field lines would actually look exactly like how we saw just now. So here's the thing, people. Here, if you look at the resemblance, the magnetic field lines produced in a circular coil will actually resemble the magnetic field lines of a very simple bar magnet, a small bar magnet. And that is what I want you guys to understand. Now, this is the same case with solenoid as well. I'll show you that in a minute. So that is what it would look like. Now, what you have to understand is this, guys. If the current is passing in the anti-clockwise direction, if it's going in the anti-clockwise direction, then the side that you are facing, if the current carrying conductor is this way and you're facing that current carrying conductor, that side that you're facing would be the North Pole. That would be the magnetic North Pole, the side that you're facing. If the current is passing in the clockwise direction, then the side that you're facing is the magnetic South Pole. So here also you have a North Pole and South Pole. This will be the North Pole, this will be the South Pole. So basically that's what I'm trying to say. So if the current is passing in the clockwise, so you see this is the clockwise direction, the current is passing in the clockwise direction. So the side that you're facing, this would be the North Pole, the side that you're facing would be the North Pole, and the other side would be the South Pole. As simple as that. That's all, guys. All right. So that is all I have to say for the circular current carrying conductor. Now let's talk about a solenoid. Now, first of all, guys, a solenoid is let me explain the word first. Solenoid means it looks like a cylinder. It basically looks like a cylinder, the cylindrical shape. So basically that is what is called a solenoid. So basically the shape would look like this. So it looks like a spring, basically. It looks like a spring. So this is what a solenoid looks like. It basically looks like a cylinder, like a spring cylinder, and the shape of that is what is called as solenoid. Now, this is what it looks like. It looks like a cylinder. So it has many circular turns like this. Generally, we use insulated copper wires. So what you do, you just wrap the insulated copper wire around like a spring-shaped structure, and that is what gives you a solenoid. Now, in a solenoid also, guys, if you look at if you check the current carrying, if you check the magnetic field around it, this is what it would actually look like. Now, how did you come to this? Again, use the exact same principle, the right hand thumb rule. So let's say that the current is passing from here. So let me just use a different color for you to see carefully. So then let's say the current is passing through here. So if you place your thumb this way, the magnetic field lines, now you can't imagine that it basically looks like this, on facing towards that side. All right. Now, imagine for each and every point, there are circular magnetic fields like this. Now, I've told you in the first session, that magnetic field lines can never intersect with each other. So what happens is that they merge with each other and form a magnetic field line which looks like this. Now here also, it actually resembles like your magnetic, that is your, North and South Pole. It's like your simple bar magnet. So North and South Pole, it exactly resembles like that. Sorry. Yeah, my diagrams are a little hopeless. Yes. Yeah, this is why I never took biology. Anyway, so this is what it looks like. And if you look at it, it actually resembles like a bar magnet itself. and that is what the magnetic field lines look like for a solenoid. And if you look at it, it's very similar. It looks very similar. So that is what you have to understand about a straight line conductor, circular loop, as well as a solenoid. As simple as that. So like I told you, the direction of the magnetic field can be found out using this exact same thing, but here for a loop. Now because they all intersect with each other, if you were to draw several such circle, imagine there are several such circle, imagine each of these circle having their own magnetic field one after the other, so they'll obviously intersect with each other. So you cannot have those magnetic field lines intersecting with each other, so they merge to form the magnetic field line, which looks like this. As simple as that. Alright, so let's do some questions and answers. But before that, guys, I have an announcement to make, and which, my friends, is this. Just give me 2 minutes of your time. It's a very important thing that I'm pretty sure that you could relate to this very, very easily. So here's the thing, guys. During this lockdown especially, many of you guys came up with a lot of problems, right? You faced a lot of difficulties. Now, apart from the health issues and stuff, there are a lot of help that you needed in terms of education as well. So a few problems that you guys faced was, sir, my doubts are not getting cleared. I'm putting up on there are different websites, but then it takes about 24 hours to 48 hours, and I really don't want to wait for 24 to 48 hours to get my doubts cleared. The other problems is that, so notes, we are doing our best to download, like we are actually putting up the link to download the notes at the bottom of in the description panel, but that is just not enough. It is enough to about 95 to 96% of it, but still there is that 4% missing. So how do I fill up that gap? Tests and assignments. So how I can't just I can't just read everything and just go vomit it in front of the exam paper. I can't do that. I have to practice as well. So where do I get tests and assignments? Competitive exams, right? You are all I'm pretty sure that you're all very eagerly waiting for your schools to start so that you can start participating in your Olympiads and NSOs and whatnot. So you guys are all looking forward to KVPI, NTSE, so many different competitive exams, and you guys are all looking forward to that as well. So how do I get trained for that? Choice of schedule, because that is a very big problem, because sometimes the teacher comes out at a different time and you're not free during that time, you're doing some other kind of activity, so it's a very difficult thing to match all the timing. So schedule is a very, very important problem. And apart from that, the choice of language. Now we try to solve this problem by creating 2 different channels right now. There's a channel for English and there's a channel for Hindi as well, but still there's a lot of these confusion that is going on. Now we are not right now at the moment we are not providing classes in regional languages, but Hindi and English are the most spoken languages in the country. Here's the thing, guys, all these problems Vedantu has solved it. Doubts, you have a 2-teacher model inside the class. You'll have someone called as the master teacher who will teach you the session, and you'll also have someone called as a class teacher to help you clear your doubts. So whatever doubts you have, it'll be cleared instantly by the class teacher. So you get personalized attention to make sure that your doubts are cleared. You get the notes at the end of every session. You can download the notes whenever you want, how many number of times that you want, and refer to it whenever you want to. Tests and assignments. You have periodic tests and assignments, and most importantly, take those tests and assignments, because the tests and assignments that you take would help you give you a personalized report card as well, which tells you where are the topics that you're finding weak, where are the topics that you have to improve, and everything of that sort to make you guys better. Apart from that, competitive exam, you'll be trained for free for all your competitive exams, NSOs, KVPI, and NTSE, whatever competitive exams that you're planning to take, you'll be trained for free for that as well. And you can choose your own schedule. Live classes are going on 24/7. Whenever you feel like studying, you can choose that time and study with that particular teacher. And choice of your language, we're providing 2 choices right now, English and Hindi, but yes, we'll be coming up with the regional languages also soon, but for now it's Hindi and English. Alright guys, now how do you come across this, or how do you benefit from this? I'll tell you that in a minute. But apart from all of these, guys, you'll have unlimited live classes. That means that you can attend even 24 classes in a day if you want to. It's totally your choice. Even if you want to attend 24 days without sleep, if you want to continuously attend Vedantu classes, live classes, that's also completely possible. You'll have all micro courses and crash courses for free of cost. You can attend just a particular chapter. Micro courses are one particular chapter. You can study that alone. Performance report cards, like I told you, you can get a detailed report card of where you're going wrong and what are the things that you can do to make yourself better. And like I told you, personalized attention, because I told you that you have a 2-teacher model with a class teacher and the master teacher. You'll be getting the personalized attention that you need. And what you'll do is very simple, guys. Visit this website, vdnt.in/ytpro, and As soon as you visit the website, this is what it will look like. So you have to choose from 1 to 12th grade. So basically Vedantu right now is catering from 1 to 12th grade. So let's say that you're someone in 10th standard. So as soon as you click on that, they'll ask you which grade or which syllabus do you follow. Do you follow CBSE syllabus in school, ICSE or Maharashtra? For now, these are the only three things that we're providing. Future, we'll be adding more to that as well. For now, let's say that you're in CBSE syllabus. So once you click on it, you will be getting all the things that I just told you right now. Unlimited live access, interact with India's best teachers, with unlimited in-class doubt solving with the class teachers, test series and assignments, guaranteed score improvement, because obviously all of these would mean that your score would become much more better. And you can also choose the schedule of your own choice. So what you're going to do is click on get subscription. Once you click on that, this is the next thing that you're going to see: 1 month, 3 month and 6 months. I'm going to do some maths and I'm going to show you what it really means. So 1 month, the base price is 4,000 rupees. Even without any kind of coupon code, you will get the price down to 2,699 rupees. And if you use the coupon code AKPRO, remember this code AKPRO, you'll get the price, you'll get another 400 rupees discount, and you'll get the price down to 2,294 rupees. Let's say that you're someone who wants to go for the 3-month course. So if it's a 3-month course, the base price is 10,000 rupees. But if you use without any coupon code, it'll be 6,999 rupees. And if you use the coupon code AKPRO, you'll get 1,049 rupees discount, making the price to 5,949 rupees. Let's say you go with the 6-month course then. For the 6-month course, here the base price is 16,000 rupees, but without any discount, you'll get it down to 11,499 rupees. And if you use the coupon code AKPRO, you'll get another 1,700 rupees discount on that, and getting the price down to 9,774 rupees. Now, here's the thing, people. Let's do some maths, all right? So these are the base prices without any kind of discount: 2,699, 8,099, and 16,194 rupees. Without any coupon code, this is the primary discount you're going to get. For 1 month course, it's going to be the same, but for 3 month and 6 month, it's going to be 6,999 rupees and 11,504 rupees, essentially giving you a discount of 1,000 and 4,690 rupees. So if you use the coupon code AKPRO, you'll get another discount on that. You'll get the price down to 2,299 rupees, 94 rupees for the 1 month course, 5,949 for the 3 month course, and 9,774 for the 6 month course. Now, let's do some math. So let's say that you're taking about 8 classes in a day. So you have 6 subjects, right? Your science, your physics, chemistry, math, bio, math, social science and English, six subjects in total. So let's say that you're taking about 8 classes in a day. You can take how many you want. For our calculation, we'll take it as 8. So in a week, 6 days you'll be attending the classes. So roughly you'll be attending about 48 classes. Let's round it off to 50 classes because math and me, we're just not good friends. So we'll just take it as 50 classes. Now, in a month, how many classes will you be attending? About 200 classes, 4 weeks, 15 to 4, 200 classes. Now, per month, let's calculate how much do you think you'll be paying for each and every class. So for the 1 month course where you're paying 294 rupees divided by 200. For the 3 month course, 5,949 rupees divided by 6,600 because you're attending 3 months course. And for the 6 months course, 9,774 rupees divided by 1,200 because you're attending the class for 6 months. If you divide it, you'll get the price for each and every class to be 11 rupees 47 rupees, for 11 rupees 47 paise, 9 rupees 19 paise, and 8 rupees 145 paise. So basically, guys, this is going to be less than what you pay for your lace packet, which is apparently 90% filled with air. So what I'm trying to say is this, guys, that Vedantu is trying to provide education as cheap as we possibly can to make sure that each and every part of the country is getting the same quality education that all of us who are privileged enough to get. And that is what we are targeting at, and this is one of the ways to go about it. So yes, people, all you have to do is visit the website vdnt.in/ytpro and use the coupon code AKPRO, and you'll get the discounts, and you can just do the calculation by yourself and see how it goes. Alright, with that said, people, let us get back into the questions now. Let's solve some questions and see where it takes us. Here's the first question. We can increase the strength of the magnetic field by doing what? Increasing the current in the conductor, reducing the current in the conductor, keeping iron material inside the conductor, or none of these. And the answer, guys, I know you know the answer. Put it down in the comment section below immediately. The answer to this question, guys, is option number A. By increasing the current through a conductor, you can actually increase the magnetic field. So more the current is passing through it, the more the strength of the magnetic field would also be. So if you increase the current, the magnetic field would also increase. The strength of the magnetic field also increase. Second question. A circular current carrying loop can be thought of as a collection of points, straight conductor, curved lines, or none of these. What is the answer for this question? I just told you this. How do we, we can imagine that to be something like that. So tell me what is the answer in the comment section below. The answer to this question, guys, is straight conductors. I told you that the circular conductor can be divided. So I'll just take another color in 1 second. So imagine this is the circular conductor. I can divide it like, I can imagine it to be like straight lines and connect it and make a, you know, a hexagon or a pentagon out of it. So yeah, again guys, my diagrams are hopeless, I know that, but you get the idea. Third question: to increase the magnetic strength of a solenoid, we can increase the number of turns in the coil, increase the current in the conductor, decrease the current in the conductor, or both A and B. That is, increase the number of turns in the conductor in the coil and increasing the current in the coil. The answer to this question, guys, I haven't told you this, but yes, the right answer is option number D. That is, if you increase the number of coils in the conductor, the strength of the magnetic field will also increase. And obviously, if you increase the current flowing through the conductor, obviously the strength of the magnetic field would also increase. So these are the two ways to actually increase the strength of the solenoid. One is to increase the number of turns, and to increase the number of the amount of current, or the amount of current passing through the coil. As simple as that. Fourth question is, if we keep a wooden block inside a solenoid coil, the wooden block becomes magnetized, demagnetized, hot, or none of these. What happens if you keep a wooden block inside a solenoid? Would it become magnetized, demagnetized, hot, or none of these? What is the answer, do you think? Put it down in the comment section below. The answer to this question, guys, is going to be option number D, none of these. Because obviously, wood is a non-magnetic material. Why would it get magnetized? Definitely not. It is neither going to get magnetized, neither is going to get demagnetized, nor is going to get hot. The answer would be option number D. That'll be the end of this. So with that said, guys, this is the homework for today. Again, homework in the comment section below. Let me know how it was. If the current is in a loop flows clockwise, the magnetic pole developed is what? If the current in a loop flows clockwise direction, and if you're facing towards it, what is the magnetic pole going to be like? All right, that is a question. Let me know what is the answer in the comment section below. That is it from my side, guys. Thank you for joining. I hope you enjoyed today's session. I hope you learned something new out of today's session. So if you did enjoy today's session, leave a like, subscribe to the channel so that you are aware of all the videos that comes out in the future. And if you want to reach out to me personally, you can also reach out to me at anoop.manoharan@vedantu.com. Thank you for joining. See you on the next one. Take care of yourself. Stay safe and bye-bye.